Hello, everyone. Thanks for dialing in to the webinar. We still have a few participants trying to dial in, so let's give them a chance to tune in and we'll start in a couple of minutes. Thank you. So, good morning, good afternoon, good evening to the people dialing in from around the world. My name is Ling, and I'm the Director of Communications and Marketing at I4E. It is my pleasure to welcome you to the new Innovation for Electrification Showcase Series, also known as I4E, organized by I4E. The purpose of the Showcase series is to enable our members to get one step closer to potential collaborators by giving them the opportunity to directly showcase their products and solutions. So with that, I'm very happy to kick off the second edition of the I4E series on energy storage trends. This edition is powered by our member 24/7 Solar, who you will meet in the panel. This is the agenda for today. You will be joined by my colleague Rebecca Brigant, who is the facilitator of the webinar, and we'll be hearing from 5 different themes on energy storage trends. So you'll be hearing on clean power and heat, ESS tendencies, lead-acid batteries, hydrogen storage systems, and flywheel energy storage. And our members will be giving presentations on this. So you'll be hearing from 24/7 Solar, Solacia, Eastman, H2 Energy, and last but not least, Oxto Energy. Next slide, please. So about I4E, for those of you who don't know us, we are the Global Association for the Decentralized Renewable Energy Industry. We are represented by over 185 members from over 55 countries and spanning the 3 continents. If you do want to get to know our members better, we have what we call the I4E off-grid matchmaking platform, which you can consult. Next slide, please. So this is where our members work and the expertise that they have. A big bulk of our membership do a lot of good work in Africa, but we also have a very good representation in the Asia Pacific and Latin America and the Caribbean. At I4E, we are technology agnostic, so that means our members work on many different renewable energy types, be that bioenergy, small hydro, small wind, power components, energy storage, and PV. And our members also work on 2 different energy system types, such as standalone and mini grids. So if you are interested in joining the I4E family, we do offer a bunch of services and they can be summarized here. We offer 3. The first being market intelligence and business development, the second policy and advocacy support, and finally communications and marketing. So if you are interested in some of our services, feel free to reach out to us. We'll be very happy to have a chat with you about what your needs are and how we can help. And without further ado, I hand it over to my colleague Rebecca, who will be facilitating the next part of the discussion. And I wish everybody a very insightful webinar. Thank you.
Yeah, thank you very much, Dearling, for opening the session. So yeah, dear I4E community, dear friends and supporters of renewable energies, and of course, dear esteemed speakers. Also from my side, a very warm welcome to the second edition of the new Innovation for Electrification series. My name is Rebecca Brigant. I'm one of the board members at I4E and also one of the co-founders of Pineberry, who's also an I4E member, of course. Yeah, it's my great pleasure today to guide you through 5 pitches from our valued I4E members. They will present their recent innovations and success stories to us, all related to the latest energy storage trends. We will then have 20 minutes of Q&A, where the audience is invited to ask questions to the speakers. So for this purpose, please use the Q&A function of GoToWebinar. And, very important, don't forget to name the speaker who you're asking the question to, just so that we can redirect it accordingly. Please also take note of the contact details of the speakers at the end of their presentations, and feel free to reach out to them directly after the event in case you have any additional queries. And then finally, we will close with a wrap-up and final remarks. Please note that the session is being recorded and will be made available on the I4E website and the LinkedIn page. So just in case you miss a piece, no worries. Yeah, and now before we start, I would kindly ask the speakers to stick to the 8 minutes time for the pitches, just to be sure we have sufficient time for everyone to speak and also for the audience in the Q&A session, of course. Yeah, so without further ado, let's start with the first pitch. I'd like to hand over the floor to Ms. Natalie Lawrence, who's Vice President at 24/7 Solar, and she will talk about 24/7 clean power and heat for rural jobs. So please, Natalie, turn on your camera and the stage is yours.
Thank you, Rebecca. I appreciate the introduction and I appreciate you facilitating this panel. Also, I'd like to thank the Alliance for Rural Electrification for the opportunity for 24/7 Solar to sponsor this important conversation about energy storage in rural communities. I will talk to you today about our approach to storage for clean power and heat and its clear impact on development and support for rural jobs. Next slide. As our founder and CEO, Bruce Anderson, says, people need reliable, clean power around the clock, not just when the sun shines or when the wind blows. As you all know, the challenges in rural areas of developing countries are well understood. Where access to electricity exists, it is often limited. National and regional grids can be unreliable. Off-grid power is often provided by rudimentary PV installations which operate only during the day. Battery storage, if any, only lasts a few hours and often involves conflict minerals, non-recyclable parts, and either a fixed number of charge cycles or diminished ability to hold a charge after just a few years. And diesel gensets are dirty and the fuel costs are high. Next slide, please. Our long-duration heat store thermal battery supports and enables round-the-clock clean power for rural areas. Our differentiator is that 24/7 Solar can produce clean power reliably 24 hours per day in an integrated way. The company's 200 kilowatt heat store thermal battery converts surplus electricity from PV, wind, or the grid to heat and stores it for up to 20 hours, more than enough to power rural communities through the night. During prolonged periods of bad weather, heat store becomes a 21st century version of a genset, replacing diesel gensets, and it provides continuous power while reducing fuel bills by up to 90%. Heat store is different from conventional short-duration batteries in many ways. One of the most significant is that it is capable of supplying industrial-grade heat for steam production, crop drying, refrigeration, water purification, and other uses. This means that in addition to round-the-clock power, communities can attract new industries, create jobs, and increase their economic well-being. Next slide, please. How it works. So the heat store converts electricity from PV, wind, or the grid to heat using highly efficient electric resistance coils. This heat is then stored in an inexpensive, long-duration recyclable material like ordinary sand or iron slag at temperatures of nearly 1,000 degrees Celsius. As needed, air is blown through the storage container and the superheated air that emerges is used to drive a unique turbine. The turbine contains a proprietary 24/7 Solar heat exchanger that transfers the heat from storage to compressed air inside the turbine, enabling the turbine to produce electricity without combustion. The turbine runs without burning any fuel as long as the stored heat is available, which is most of the time. Even when its energy storage is fully depleted, HeatStore continues producing electricity for an unlimited time by burning a wide variety of liquid or gaseous fuels, including hydrogen. HeatStore enables communities to completely eliminate diesel gensets and their high fuel costs. In this way, the system is its own backup because its storage is long duration. It can reduce fuel costs 80 to 90% compared to diesel alone. All of HeatStore's components are factory produced, and the system has few moving parts. It can be assembled and maintained by local workers through on-site training. In more industrialized countries, many components can be produced locally as well. Next slide, please. Here is an example of the long-duration thermal heat store battery in the context of a typical implementation, leveraging the input of wind, solar, or even excess grid power, controlled by a local energy management system, powering homes and local industry. While the energy management system may leverage other forms of short-duration storage, such as lithium-ion batteries, with the long-duration heat store battery and its built-in access to backup fuel sources, diesel gensets are completely eliminated. Next slide, please. I mentioned earlier that there is a 70 to 90% fuel cost reduction with heat store as compared to traditional diesel gensets. This chart illustrates the additional advantage that, in total cost of ownership, heat store battery with PV and wind input is expected to be 50% less than traditional diesel gensets. Because one of the backup inputs to this system can be green hydrogen, we readily support a path to zero carbon implementations. Next slide, please. Lack of reliable electricity is a major obstacle to economic development and associated job creation in many regions. With climate change looming and increased global and local conflicts that affect existing fossil fuel distribution, fossil fuel-based solutions are no longer viable. By adding heat store to PV or wind implementations and removing diesel gensets, remote communities can now enjoy reliable, clean power and heat around the clock. This enables them to lower their overall cost of electricity and increase productive outputs, leading to self-reliance, job creation, reliable carbon-free local grids, lower costs, and increased output, all of which ensure economic growth and improved quality of life. Next slide, please. Briefly, 24/7 Solar is an MIT spinoff co-founded and led by our CEO, Bruce Anderson, who is an MIT alum and a pioneer in the solar industry. You can see the background of each of our experienced management and technical team, our committed, engaged, and expert board of advisors, and our global development partners with deep and broad expertise in our field. Next slide, please. Thank you for your attention and interest. Our contact information is on both the first slide and this closing slide, and I believe Rebecca mentioned you'd all be getting all of our contact information. I welcome questions today, and I also encourage you to contact us after today for more information, especially if you're interested in how to leverage our long-duration storage technology to promote economic development and job creation in rural regions. Rebecca, back to you.
Thank you so much, Natalie, for this insightful presentation and the new heat store battery. So I'm sure we'll have a couple of questions afterwards, but yeah, so thank you very much, Natalie. And for the next panelist, we have Mr. Alexander Larios, who is Head of Business Development at Solartea, and he will talk about ESS tendencies in emerging markets. So please, Alexander, stage is yours.
Hi, Rebecca. Thank you very much for the introduction, and thank you to the whole I4E team for facilitating this webinar series. It's always nice to join all the I4E members and viewership. I'll start immediately telling you a little bit about who we are, and then we'll dive into the energy storage tendencies in emerging markets. Next slide, please. Well, Solartea is a Spanish engineering company. We've been in this industry for the last 23 years, and we are totally reliant on on our global engineering approach based on human talent, technological innovation, environmental sustainability, and a high sense of social responsibility. We're divided into three main divisions, which is the Solar Energy divisions, where we promote and design all solar PV installations, energy storage systems, and mini grids. And also we have a biofuels and services divisions, which I will not talk about those today. Next slide, please. We are a company that's very much focused in Latin America and the Caribbean. It's what our whole pathway has led up to, and we're very happy with promoting energy access in that region. Next slide, please. This is Solarte in a nutshell, all right? Three main divisions: energy, biofuels, and services. As I told you, five main business lines, which is the solar PV, the hybrid power plants, or mini grids, energy access, where we also do standalone systems, biofuels, and service partnerships. Our service portfolio includes development and promotion, engineering, EPCs, asset management, integration, power purchase agreements, and operation and maintenance. We do this in more than 15 countries around the world. Next slide, please. As I said, our main business lines are solar PV, hybrid power plants, energy access, biofuels, and service partnerships. In solar PV, we have developed over 300 megawatts worldwide. We own assets for the equivalent of 21 megawatts. We have developed also in different parts of the world, not just in Spain, over 18 megawatt hours of energy storage systems currently, and more in our pipeline. We do service partnerships for some of the most important brands in the solar PV industry, like SMA. And we are very proud of our standalone system, if we may call it that way, because we try to innovate. And well, we are doing a solar generator, like we like to call it. I encourage you to visit arcapower.com to learn more about the solution. Next slide, please. All right, so let us explore some current energy storage tendencies. All right, energy storage, as you know, is currently the talk all across the energy industry because it is a crucial tool for the integration of renewable energies and unlocking the benefits of a clean, resilient energy supply. So first tendency I want to talk about it's energy storage systems as a service and levelized cost of storage. Well, energy storage as a service is currently the most significant business model trend, in my opinion, because it englobes so much more. Energy storage systems as a service, they use artificial intelligence, blockchain, predictive analytics to integrate energy storage successfully, which results in greater flexibility for grid stability and for utilities, as well as more options for the area sector, right? In emerging markets, additionally to flexibility and rapidly falling prices, these advances in digital technologies are prompting innovative storage business models that were nearly inconceivable a few years ago, maybe even 1 year ago. That is what we see in energy storage systems as a service. And along with the levelized cost of storage metrics, which basically apply the same principles that levelized cost of energy applies to power generation solutions, well, energy storage systems as a service have accelerated the development of the solar and energy industry. This evolving metric of the L cost, if I may abbreviate it that way, it definitely helps project developers and investors better analyze and calculate the capacity and reliability of energy storage systems, as well as allowing stakeholders to make more intelligent decisions all across the board and to actually know how to support their projects. Next slide, please. Second tendency, it's ownership and revenue, right? Now we're diving into the regulatory framework in policymaking. Well, this is very important as well because ownership and revenue models have a significant influence on the methods of financing energy storage systems, right? In emerging markets, ESS ownership is opening up as they can now be owned by IPPs. We now see a lot of more IPPs in Africa, especially, or be directly aggregated to states' transmission assets, right? When owned by the states, ESS are financed through debt or grant funds, or even state treasury funds, right? And when it's from an IPP standpoint, well, it usually goes financing through project financing models, which basically allow the lender to look at the future revenues pledged by the IPP, right? I think it is paramount to keep focusing on increasing function-based revenue models for energy storage systems, because this will enhance a fund allocation, because the lower the risk, the lower the financing costs. Also, function-based revenue models will help better manage risk, which in turn will also reduce financing costs and attract more historically risk-averse investors. Among these functions, we can find frequency regulation, fixed power, peak shaving, or even discharge energy, among others. Next slide, please. Oh, increased deployment. That's the third main tendency, because all these tendencies, they englobe, as I said, digitalization and other factors that are currently shaping the whole energy storage system picture, right? But increased deployment, driven by expanding electric markets and the DRE sector flourishing although in early stages, costs are dropping while performance is improving, especially in lithium-ion batteries. But also, grid modernization is helping spur the deployment and development, technology-wise and cost-wise. We now see hydrogen and lithium titanate, for example, gaining traction in their development. And you can see this in the projections that the ESS market has. It will probably reach the terawatt hour in 2030. And well, mini-grids have also gained relevance as a key player to close the gap in energy access for grid operators, as well as communities, local governments, and multilaterals, development banks, and other stakeholders. So next slide, please. I'll go to my takeaways. And as I say, despite recent advances, where we now see governments worldwide growing increasingly proactive in promoting energy storage solutions, there's still plenty of room for regulatory improvements. And well, as demand for renewables and the need for energy independence and climate change resiliency increases, long-lasting ESS will become more critical. Supply shortages will remain a challenge for the short term, but there's no easy fix in there. The EV and DRE industry's growth means more opportunities for ESS deployment. And well, it is nice to have increased appetite for risk capital. That's all my part for today. I'll gladly be having any questions you may have at the end. Thank you, Rebecca. Thank you, everyone.
Thank you so much, Alexander, for sharing your experiences and insights. Yeah, really exciting to see what trends are going on and what you could observe. So yes, thank you very much, Alexander. See you later again at the Q&A session. And now we switch over to Mr. Ashish Saxena. He's the general manager at Eastman, and he will talk about suitability of lead-acid batteries for off-grid applications. Ashish, are you with us? So please unmute yourself and turn on your camera.
Yes, good afternoon, Rebecca. You can hear me?
Yes, I can hear you.
Okay, great. First of all, greetings to my fellow panelists, and my apologies that I'm joining from the phone. There's something wrong with the IP for GoToWebinar here, so unable to access from my laptop. So without further ado, I wanted to basically make a little clarification about and talk in detail about the suitability for lead acid batteries, especially for off-grid, microgrid, or mini-grid solar power projects that are quite the rage right at these days in Africa. You might be well aware about the trend that more and more project operators, independent power producers are going for lithium ion pack battery that basically offers them a significantly higher cycle life. So in a way, the following slides that I'll go through will give people an idea, especially those who are in the off-grid power segment, for how this lead acid and the lead gel type of battery can make more commercial sense as compared to the other progressive type of batteries. So just a quick history. The lead acid battery has been around for over 100 years now, and the gelled lead acid type of battery was developed sometime in the 1950s by Sonnenschein in Germany, and due to its fused type of electrolyte that is made along with mixing with fumed silica gel, that gave it a kind of a sealed, maintenance-free and very safe operating parameters, including enhancing its service and cycle life, that allows it to effectively compete with the most the advanced type of energy storage systems, including the lead carbon and even some type of lithium ion type of batteries. So as we know, energy storage systems deployed for frequency regulation and energy buffering uses lithium ion batteries. So this is because, unlike lead acid, lithium batteries can be rapidly charged when excess energy is available. But where the advantage of the lead gel or the lead acid type of batteries come in is that they can be very easily and are still commonly used in UPS or in most of the electrical power backup appliances wherever they need economy range products, and even in the deep cycle applications where there is a daily discharge required up to 50% depth of discharge, or even up to 80% depth of discharge for some off-grid solar type of projects. Next slide, please. Yeah. So in continuation, unlike lithium batteries, lead acid battery banks do not have a specific cutoff point at a certain depth of discharge. So in an emergency situation wherein you need to draw excess energy, they can continue to provide power backup until the voltage reaches the inverter cutoff, although it does affect the battery life and everything. But then, unlike a lithium ion battery, they're not controlled by a BMS. They can be used as much as you need in times of emergency. This is one of the most important, what you can say, standout point of the lead acid battery. Although it is like you can say, it's USP. So real world applications indicate that lithium ion basically has a significant higher lifetime cost when compared to lead acid in moderate climates between temperature ranges of up to 30 to 35 degrees centigrade. And so this is where the lead gel technology basically comes in to close the gap of lifetime cost by having extreme temperature tolerances. The lead gel is basically proven technology. It is installed in the deserts of the Sahara in countries like Burkina Faso, Mali, and it has worked perfectly in sub-zero temperatures in Canadian off-grid power projects. So next slide, please. Yeah. So this is basically a brief overview of what constitutes a tubular gel battery. It is more or less very similar to a normal conventional flooded. The only difference being a few changes in the advanced polymers that are used in the valve design for temperature control and regulation to increase its tolerance level and increase its moisture retention through use of polyethylene and polypropylene monomers, and improved construction of the tubular plates, as in the thickness of the plate varies between 2.2 to 2.8 mm in dia. That allows it the ultra deep cycle discharge capacity. And it's a special addition of the calcium alloys. It's like a industry differs from company to company based upon their patented chemical mixtures. The use of fumed silica gel that allows it to have a sealed maintenance-free service life, and use of some moisture retention additives that allows it to not become dry over sustained usage in extreme conditions. Next slide, please. So if you compare the gel type of lead acid battery, it is highly compatible with 99% of the inverters in the world as of right now, both for low end, commercial, industrial, and residential usage, low end or high end, as the case may be. It is a well-proven technology with a very low risk of thermal runaway, and it is easily recyclable. The most important part being a renewable energy industry product. The end of life processing matters very much, because anyone who invests in bulk amount of batteries, be it lead acid or lithium, has to deal with the scrap product when the life is over. So lithium being in its nascent stage as of right now, in continent like Africa, it is very, very difficult for people to invest in lithium recycling. It is very cost extensive. The technology is way too advanced for each what you would say investor to have a facility to deal with lithium, since it is highly reactive to multiple components. Hence, a very sensitive equipment and a facility is required. So this is not the case with lead acid battery. You would be interested to know that almost 85% of the components of a lead acid battery, including its polypropylene container, its gauntlets, its tubular plates comprising of lead oxide, or calcium oxide, or silver oxide, and its the electrolyte inside is recyclable easily. It can be repurposed into some other products after the end of use. So this is where it is truly environment friendly as on date, as compared to a lithium system. Next comes due to its heat dissipation and so this basically, we can go ahead. This table basically gives an idea of the comparison between the energy density, the maintenance required, the initial cost per watt for an average, let's say a 10 kilowatt solar power project, the cycle life at 80% depth of discharge, right, and the temperature sensitivity and the voltage increment. So this table would basically show you in a way that if you calculate for a small or a medium-sized power project, the tubular lead gel would give you a more value for money. And just quickly wrapping up in the safety and environmental impact, I've covered the basic points that it is highly recyclable as compared to lithium ion, and it remains eco-friendly and very comparatively less hazardous to human health, and very easy to recycle. So I think that basically wraps it up, and I'm open to questions at the end of the session, if any.
Thank you so much, Ashish, for your insightful presentation and presenting to us your new lead acid battery. So yeah, we will see you again or listen to you again in the Q&A section. Thank you very much. And
Sure.
yeah, next I would like to hand over to Ms. Sandra Liz Hon, who's director at H2 Energy, and she will speak about off-grid electrification with hydrogen storage systems. Please, Sandra, stage is yours.
A very good afternoon to everyone, our fellow members and panel speakers today, Ms. Rebecca, who is facilitating this webinar. Thank you for having us to participate in this webinar session on innovation for electrification. I'm afraid I have a challenge with my camera again, organizer, but I would just continue. Next. H2 Energy is a young company and proponent utilizing green hydrogen as a sustainable off-grid solution for rural electrification. Next slide, please. We are a member of the bigger ANCA group, a member of the Sarawak Hydrogen Association, as we also recognize that we are a member of I4E. And in the end of last year, we have also entered into affiliations with our licensee HydroX Gen in Australia to further broaden our expansion to the market in Australia itself to capture the immediate market requirement there. Next slides. Our origins, we were given the opportunity to commence a proof of concept pilot project by the Ministry of Health in Malaysia for a rural clinic at Long Loyang in Sarawak, which is about 183 kilometers from the oil town of Miri, with very challenging terrain. And we are honored that the pilot study has successfully commenced, and now the hydrogen's H2 energy system is now successfully powering the rural clinic and allowing 24/7 access of energy. Next slide. This is just to share with you some of the photos that was taken at the pilot sites, the powerhouse, the interior and the exterior of the setup of the system there. And next slide. Our commitment continues going beyond the rural clinics. We are seeking to expand beyond, not just in Southeast Asia, also beyond to the other rural electrification market, broader in Africa, in MENA, and even to a certain part of Latin America. Next slide. Here, I would like to share with you our innovative solution. It's basically a very simple building block because we are talking about rural electrification. So it has to be simple and quick setup, especially in that complex and challenging terrain. So what we need is basically to harvest renewable energy, whether it's solar, wind, whatever is available at the site. That energy, that renewable energy, will be harnessed for immediate use and storage. And at night, at the same time, it will power the electrolyzer, where we produce hydrogen and oxygen, and then the oxygen will be released, water will be circulated back, the hydrogen will be stored in the energy storage tank, and during intermittence or for night use, that's where the fuel cell would harvest the hydrogen from the storage tank to continue ensuring the sustainable and reliable power supply to the rural clinics or rural facilities. And this system has also been aided by our energy management system and the control and monitoring app, which actually ease the operation team in their operation and maintenance. Especially this can be done also from remotely from our control center, which is in the downtown. Next slide. The key benefits of and the operation benefits of the system is that it's quick and easy to implement. It's reliable and quality DC power. It has very few moving parts, which would bring down the cost of maintenance, zero emission, a long lifespan, and basically it's also allow a very robust and high efficiency for ongoing electricity supply in rural settlement or rural community. These are the key areas that I have shared earlier. It's very cost competitive also. It's scalable, so it depending on the requirements and of the electricity requirements in the location. We can scale it up as they expand or improve or upgrade their services, because so it's customizable. And because these are meant for rural electrification, so the system is modular, compact, and make it easy for transportation. Next slide, please. This is how an example of the easy site installation that you can see. You can place it indoor as how we show you in our pilot site earlier, or we can also place it outdoor with outdoor shelter and fence. Next slides. So it doesn't take much big footprint actually. So it's a standalone system, easily set up in rural facilities or rural villages. For a village where this is basically a building block to show how it works for a village. In the day, as I mentioned to you, the solar can power the electricity directly, and concurrently it can also power concurrently will power the electrolyzer. Water will be fed in, H2 will be broken up, and then the H2O will be broken up and H2 will be stored in the energy storage tank for night use with the support of the fuel cell, and water would be recycled back for continuous usage. So this is how we can ensure a continuous supply of energy to the rural communities. Next slide, please. This off-grid application, H2 energy, is not just applicable to the rural clinics as I shared earlier, it's also applicable to rural villages, other facilities like rural schools, telco towers, decentralized communities like the work sites and islands. Next slide, please. As we shared earlier, our origins is in Southeast Asia. We have expanded through our affiliations to Australia, and now working towards expanding into MENA, South Africa, and also CPLP. Next slide, please. Right, this I have explained earlier, so I will quickly go straight to wrap it up with the next slides. Basically, what we like to emphasize here is this, that we are catalyzing green hydrogen as sustainable, decentralized, off-grid solutions. This to embrace our ESG principle and seek to be at the forefront of a clean energy future. And we welcome questions from audience after the webinar. Thank you very much.
Thank you so much, Sandra, for sharing your experience and your pilot project with the Powerhouse. Sounds really exciting. Yeah, you just mentioned it, so please, dear audience, feel free to post your questions here in the Q&A function already now during the presentations, and then afterwards we can discuss them at the Q&A session. So once again, thank you very much, Sandra. See you later at the Q&A session. Hopefully your camera will join us again. But anyway, really insightful. So yes, and then last but not least, I would like to hand over to Mr. Michael Wilmot, who is CFO at Oxto Energy. And Michael will talk about the new generation of Flywheel energy storage to power the global energy transition. So please, Michael, welcome. Stage is yours.
Thank you, Rebecca. Good evening, afternoon, morning to everyone, wherever you are. And thanks to the I4E for the invitation to present to this webinar. So my name is Michael Wilmot. I'm the financial and also commercial director of Oxto Energy. So we are an energy storage business based in Guildford, UK, not far from London. And we have developed a new generation of Flywheel energy storage technology with the objective of powering, helping on the global energy transition. So next slide, please. Just a bit of background. So we come from the space industry at the beginning, so where we developed small subsystems to put on board satellites. One of them was small flywheels, as you can see in the central picture. This was to actually replace batteries on board satellites for different reasons. And upon this success, we wanted to bring it back to Earth to commercialize and adapt the technology for energy storage applications. So next slide. So what is very important for us, and that the mission we have, is that we find out that with all the transition we have in the energy, so renewables, electrification of transport and everything, there's quite a high challenge to balance and maintain stable electrical systems. So the power quality is very critical to everyone, actually, to every electricity consumer. So that's where our system actually can really contribute to help on the energy transition. So next slide, please. So what we developed is a flywheel system. So it's basically a battery, mechanical battery, if you want. It stores energy as kinetic energy of a rotating mass. And so the faster it spins, the more energy you store. The particularity is that we took a very specific design, and this heritage from space industry made us think about a technology that is very simple, so can be easily manufactured, mass-produced. We got rid of all complex components as well that can either lead to failure or to expensive replacement or capex. And also we made it this technology with that almost doesn't require any maintenance over a long lifetime of 25 years. So that's the particularity. And in terms of performance, it has unlimited cycling capabilities, which is interesting. A fast response and a high power, high efficiency, round trip efficiency. So this technology is really made for applications that have quite a high cycling or require fast response and high power instantaneously. As you can see, it can be installed above ground, either in containers or whatever, because there's no even cooling system associated to the technology. Next slide, please. So you see the particularity, there's other mechanical batteries and other flywheel existing technologies existing, but our particular product is that the particularity is that we've made something that is way more smaller and easier and cheaper to install as well and to maintain. So that's a big particularity. If you go next slide, please. So all the applications we can deliver are related to the power quality, as I was mentioning earlier. First of all, we have anything related for industrial customers, basically to maintain power quality. Also, we can help on energy recovery and and energy efficiency applications. We can also help on the charging infrastructures for electric vehicles and on the stability for the grid. Next slide, please. So the related to industrial, so we can provide UPS, voltage stability, also cap the help on the when you have high rush current, and generally it generates peak loads. So we can cap this and make sure that there's no the demand charge for the industrial is not too high. So here we can serve different industries. Really, we've had we start projects with data centers, for example, but also with agricultural sector for factories of transforming goods. So it's very various. Next slide, please. Then energy recovery. So you can have, for example, trains that when they decelerate and you have regenerative brakes, you can regenerate this energy, store it in our flywheel, and reuse it later for any type of use. And this is same principle for elevators, cranes. When you lift down, you can save energy to lift up, then to use it for lift up afterwards. So it's basically energy, improving the energy efficiency of those systems. Next slide, please. So on the EV charging, where we can really help is as a power booster, because most of the problems is that first of all, you don't have the power necessarily when you want to have it, when there's a vehicle. And for applications where time is of essence, like fleets of vehicles, commercial vehicles or buses, in this type of applications, it's relatively difficult to find solutions to help on this. So our solution can help on it. Now, next slide, please. And finally, on the grid stability, so we can provide frequency, voltage control, and even inertia support for any size of grid, so microgrid to large grid. Next slide, please. So we have delivered already a system in France for a smart cities project that has, it's a microgrid that has many different technologies, including our flywheel, which has a central role of balancing in real time the system. And we are working on several projects in the UK, North America, and in Asia. For example, in Canada, there's an interesting project that is actually to integrate the renewables for microgrids for remote communities. And the role of the flywheel is really also to balance the microgrid and cope with all the intermittencies. And then we have application for UPS in Japan and also in India to be confirmed, but that will be likely around UPS applications. So that's you could go last slide, please. Yeah, so that's basically my presentation. So you have my contact details on this slide, and yeah, we are members of different energy storage associations, like in New York and also in India. We've been part. We are part of the 1000 Efficient Solutions of Solar Impulse Foundation as well. And so thank you very much for this time, for this opportunity, and happy to answer any question in this panel. Thank you.
Thank you so much, Michael, for your insightful presentation. It was really great to learn more about your projects and activities. Yeah, so right now we have reached the Q&A session. So I would invite all speakers to switch on their cameras again, please. Join us. So while everyone is tuning in again, thanks, dear audience, for being so active and posting a lot of questions. So I can't promise we can answer all of them, but of course we'll do our best. Please, in case your question cannot be answered right now, as I said in the beginning, feel free to reach out to the panelists directly or to my I4E colleagues or to me, of course. Yes, so thanks very much again, dear speakers, for your pitches. So now it's time for the audience. So we have one question, starting in the same order now, to Natalie about HeatStore. So the question is from Gabriel Kreuz. The installation of a HeatStore looks complex, which usually means long and costly installation time compared to typical lithium solutions. Can you please comment on expected installation time of a typical system, let's say for argument's sake, 1 megawatt hours of stored energy?
So our solution is a turnkey system. It's modular. And so you're basically procuring modules that are shipped and put into place and hooked up to the associated power supplies, whether it's wind, solar, grid power, hydrogen. So it's very easy. I think that the time required is dependent on the shipping, but in terms of the installation and hookup, it's not going to take very long, days, weeks at most. Thank you for the question.
Sounds good indeed. Great. So then we have a question for Alexander from Solatia. Sorry if I don't pronounce it correctly. Chanchal Kumar. What kind of ESS is Solatia into?
Oh, thank you for the question. I will not try to pronounce it, but thank you very much for the question. We have definitely a knack for using lithium ion, and we don't try to go to lithium titanate. I like very much, by the way, what Michael presented today, but we do lithium ion. That's what we do. I think we're doing, yeah, just lithium ion. I'm sorry, because that's what we feel has the best the best ratio of quality, price, and safety, right? Efficiency. So I think overall, it's what we feel better deploying in very isolated regions, just in terms of durability. I think at least until now, it has worked better for us in this project, because in off-grid projects, they're usually very far apart from technical support arriving quickly, right? So, well, that is what gives us a better balance in all the projects.
Okay, thank you, Alexander. Then we have a question from Alexandros Germanis. Thank you all for the insightful presentations. What is the LCOE and or the dollars per kilowatt hours of each of your respective systems? So
what was the second part of the question?
The cost per kilowatt hours.
All right. So the LCOE, it's the levelized cost of energy. It's basically a metric that takes into consideration all the costs actually throughout the lifetime of a solution, right? So I think cost per kilowatt hour, that's a very open and tricky question at the same time, because this is gonna vary from project to project. There's no, I think, right answer for this one.
Okay, maybe Ashish, do you have something to add on this?
Yeah, see, I can give a ballpark figure. My apologies to Mr. Alexander. I know we are pitching two different, we're on the opposite end of the stick, but like a typical lithium ion system would cost around somewhere around maybe $200 to $300 per kilowatt hour, versus roughly around $70 per kilowatt hour for a lead acid or a lead gel battery system. This is a very rough estimate. It depends upon manufacturer to manufacturer, and in no way does it project that, like there's a quality difference. I mean, it varies quite a lot, but these are the rough numbers. Yeah.
Thank you, Ashish. Natalie, you want to add something?
Sure. right now we're quoting about $100 per kilowatt hour. And as the other two speakers have said, it's really dependent on the location, the installation, all of that. But $100 per kilowatt hour is what our target is right now. And that's with volume production.
Okay, thanks, Natalie. Michael, Sandra, anything to add from your side?
Yes, Rebecca, just to share, based on our pilot project for a standalone system of that capacity, we are capacity of what we have shared earlier, 15 kilowatt day, 10 kilowatt night, peak load of 2.88 kilowatt. We are talking about $2 and about $2.60 per kilowatt hour. That's also very depends on the complexity of the location.
Mm-hmm. Okay, thanks, Sandra. And then Michael, want to add?
Yeah. For us, we don't really talk about price per kilowatt hour because we are more on the power storage in a sense. So for applications that require quick rush of power, so it's not really applicable. But we look at more the lifetime cost of the project, and it really depends on some parameters like number of cycles and so on.
We cannot hear you, Rebecca. I at least cannot.
Just turn off your microphone.
Oh.
You can switch him on again. Okay, I think now it's better, right? And here there's no more sound. Perfect. Okay, great. Then we have another question of Roberto Rizzo for H2 Energy. So are there any particular safety rules to be respected, in particular for storing the hydrogen inside the buildings, or is hydrogen not considered dangerous? So please, Sandra, this one's for you.
Thank you for the questions. I will not go too technical because I do not have my engineers here with me. Yes, there are protocols that we observe. It basically is very critical to have sufficient vent for any leakage, because hydrogen is the lightest, I would say, gas in the universe. So it would just disseminate quickly into the air. There are safety features that install the system where there will be a shutdown if it doesn't meet the operating parameters. And the tanks are low pressure at 35 bar, so it's something that that has been tested to be safe to be operated in a rural site. However, we still need to observe all the protocols as with any gas facilities.
Okay, thank you very much, Sandra. I hope this answered the question. Then we have a question from Mayank Bhargava for Michael. Can you share experience, if any, of a commercial grid stabilization site using the Flywheel technology?
So the question is around the installation we've already implemented, is it?
Yeah, so he's asking for a commercial grid stabilization site using the Flywheel.
Yeah, so there are already existing sites, not necessarily where we are at the moment. We've deployed one system, and we are currently deploying another 3 systems, the project I was presenting. But flywheels have already been deployed in firstly in the US back in 2010, 2012 for grid services for frequency control. And there's also flywheels existing for remote sites, definitely. So we've worked actually on the feasibility study on the project for Africa to provide stability for a factory that has lots of outages and lots of voltage, very large voltage variations. And so the flywheel in front of it would solve these issues and would also allow the switching between grid, solar, backup generator quite quickly. And I like a UPS system.
Okay, thank you very much, Michael. Just a quick remark. So a lot of people in the audience are asking for the slides. So yes, the slides, so not the slides will be shared, but the recording will be available on the I4E LinkedIn and YouTube channels. So no worries, you can have a closer look later again. Yeah, then we have another question to Natalie. I think maybe it's also something everyone can contribute. But first, Natalie, please, what are the main challenges to bringing your energy solution to markets? Oh, and please unmute yourself.
Sorry about that. Thank you for the question. I appreciate that. The main challenges is really time, because we are in the process of finishing the development and closing our first agreements this year. We have initial installations planned later this year. And at this stage, I don't see any major challenges with this technology. Everything that we're using is proven technology that is integrated within our system. So right now, it's really a matter of getting that first installation in place, and perhaps we will learn more at that point. But I don't anticipate major challenges.
Okay, then maybe Alexander, what are your challenges with Solartia, bringing your systems to the field?
Well, I think those should be policymaking, definitely policymaking. I think we need, at least in the regions that we're focused on, I mean, we need governments to include DRE programs in their national plans, you know, because if they do not do that, and if they don't focus on capacity building as well, on standardization, I think it's going to be more of what we've endured up until now. It's going to be a slow work. I mean, we're very passionate about what we do, so we're not going to stop. We're trying to drive change, but I think in the regulatory framework, it's what those challenges present themselves.
Okay, thank you very much. Sandra, what about your experiences and challenges?
Well, through the pilot study, we have actually evolved and learned a lot from our experience. So basically, as shared with Natalie, we are also a proven technology that has been applied in other industry. We have scaled it down for the purpose of rural electrification as a standalone system. So we have improved in terms of size, in terms of how it can be modular. I think the bigger question now is how we can scale it up to projects that can be part of the government rural transformation program, whether it's the rural health facilities to connect them for 24 hours of villages, and how the financial institution would see this as part of the a new economy that will provide job, economic multiplier, especially after this post-pandemic, and come up with financial instruments that can help us to scale out and roll out this project throughout, not just in our own domestic market, but also globally, where rural electrification is very much required.
Okay, thank you very much, Sandra. Michael, you have any remarks on that? Challenges of going to the market?
Yeah, so like every, I would say, like every new technology, so we've, first of all, it's around financing the business. So definitely it's been a challenge for the last 4 or 5 years of development. And now that we are in the phase of the production, this is more around the manufacturing. So we've had also our learning curve, I would say, and our takeaways. But now we have, for instance, we have a new shareholder that has experience in manufacturing, so that's quite helpful for us. And so we are, so if you solve, these two issues, in terms of deployment and so on, and regulation, that's fine. We don't face particular challenges on this. But yeah, this is more about supply chain delivery, these type of challenges currently.
Okay, thanks very much, Michael. And then finally, Ashish, do you want to share your challenges with us?
Yeah, see, in with respect to rural electrification, we've had a mixed response across several countries. Like, for example, what you would say, economy segment, markets, something like Myanmar, Laos, or Cambodia. This is somewhere where local communities, backed up by their local self-government agencies, they prefer to have these kind of micro grid or mini grid type of systems, wherein they actively promote such investments, or even rural electrification projects. And it is in these areas that companies like us come in with our respective conventional type of lead acid or lead jet type of product, because of its affordability. And similarly, Africa remains a very prime market for us, specifically because as per the data that we have, just around 38% of the rural electrification projects are in active, what you can say, implementation. So the scope for 100% of the African continent, and bringing power to each and every consumer living in each and every African country is still to be done. So the scope for everyone is there, not just for companies like us, but even for medium end or high end segment who require lithium ion systems.
Okay, great. Thank you very much, Ashish. And also, yeah, time is up now. So we haven't managed to ask all the questions, but please, again, I'd like to ask the audience to reach out to the panelists then after the session. So yes, so now we've arrived at the end of this webinar. I would like to thank again our esteemed speakers for their exciting pitches, and of course also the audience for their active participation, because after all, that's what makes a lively webinar, right? Also many thanks to 24/7 Solar, who has powered this webinar. Yeah, it was really exciting to have you all here to follow the fruitful discussions and exchanges. And well, in a nutshell, what we've seen is that energy storage systems are pivotal in the DRE sector, not only to solve the intermittency issues of renewables, but also to ensure the economic and environmental sustainability. Well, this is why I4E continuously advocates for the requirement of increased innovation in the energy storage field, and also their integration in DRE projects around the world. So therefore, companies and organizations in the audience who wish to work with us with I4E in this field, you are cordially invited to consider joining I4E membership. Please feel free to contact us today at I4E@ruralelect.org. So once again, thank you very much, everyone, for being with us on the second webinar of the Innovation Electrification series, which was powered by 24/7. Many, many thanks. I wish you all a wonderful rest of the day, and well, see you next time. Bye-bye.
Yeah.